You know, every once in a while, a scientific paper comes along that's, well, it's just so ambitious, so out there, you don't know if it's going to be a game changer or just completely off the wall. But one thing's for sure, it's never boring. Today, we're diving into one of those, a paper that proposes a completely radical new place to look for consciousness itself. All right, let's get into it. I mean, it's the big one, right? The ultimate mystery. That feeling of being you. The experience of seeing red, or hearing a song, or just being here, right now. Where in the world does that come from?
So the textbook answer, the one we all kind of know, is that it's all about neurons firing in the brain. But this paper, it says, hold on a second. What if that's just the surface? What if, to find the real engine of consciousness, we have to look much, much deeper?
Okay, so let's take that journey inward. To really get this theory, we have to push past the usual brain activity stuff. We're going to have to shrink ourselves down, go right through the neuron's outer wall, and explore its inner architecture.
And when we get inside, we find these amazing things called microtubules. Now, in your standard biology class, you learn they're like the cell's skeleton. They give it shape. They're also like a tiny railway system moving cargo around. Super important stuff. But this paper asks a really wild question. What if their most important job is something else entirely? What if they're also a clock?
And this, right here, is where we get to the absolute heart of this radical new idea. This is where things get really, really interesting. The paper makes a claim that is, well, it's bold. It completely reframes what these tiny structures might actually be doing.
And there it is. That's the bombshell sentence. Microtubules are fractal time crystals. It just sounds cool, doesn't it? But what on earth does it actually mean? Okay, let's break that down piece by piece.
So a normal crystal, like a grain of salt, we get that. It's a pattern that repeats itself in space. Super orderly. A time crystal, though, and this is a real thing in physics, is a system that repeats its behavior over and over again in time. It's got a rhythm, a stable pulse that just keeps going.
Now, for the other word, fractal. You've probably seen these before. It's a pattern that basically repeats itself, but at different sizes. You know, like a tree branch that splits into smaller branches, that split into even smaller ones. The same basic design rule applies whether you're zoomed way in or zoomed way out.
So when you put those two ideas together, fractal and time crystal, you don't just get one clock. No, you get an entire orchestra of clocks. You get a whole hierarchy of rhythms, all nested inside each other, vibrating at different speeds, on different scales, all within this one tiny structure. The cell skeleton isn't just a scaffold, it's a timing lattice.
Okay, I know what you're thinking. That is an absolutely extraordinary claim. So, where's the evidence? Well, the paper doesn't just throw this idea out there. It follows a few fascinating lines of reasoning, like clues in a great scientific detective story. And we're going to look at 3 of the biggest clues they follow. First, some really interesting resonance patterns that have actually been observed. Second, this cool concept they call the quantum underground. And third, what might be the biggest clue of all, the puzzle of anesthesia.
Okay, so check this out. This is where that whole clocks inside clocks idea gets some real teeth. Researchers have pointed to evidence that different parts of the exact same microtubule seem to be humming along at wildly different frequencies. You've got these little tails vibrating in the kilohertz range, then the main structure buzzing in the megahertz, water inside it at gigahertz, and then tiny parts of it oscillating in the terahertz range. It's a full-on musical chord, a whole tower of rhythms all coupled together.
But hang on a second. Isn't the brain supposed to be, too warm, wet, and noisy for any of this delicate quantum stuff to happen? It's a huge objection. Well, the paper offers a really clever way around this, the quantum underground. The idea is that there are these special little pockets inside proteins that are shielded from all that chaos. They push water out, creating these tiny, protected zones where these quantum vibrations could actually survive.
And that leads us to maybe the most compelling clue, anesthesia. Think about the logic here. Anesthetics turn off consciousness. But they're a weirdly diverse bunch of chemicals. They don't have much in common. So what is their one common target? Well, it turns out many of them seem to work by interacting with these exact quantum underground pockets. The theory is that they don't shut the brain down, they just detune the orchestra. They disrupt the vibrations. And if that's true, it's like a giant flashing arrow pointing right at where consciousness might actually live.
So, let's step back from all the tiny details for a second, because if any of this is even close to being right, it offers a totally different way of thinking about life, about ourselves, and about consciousness itself.
I love this quote from the source material. It just nails it. We tend to think of life as a thing, a static object, But it's not. It's a process. It has to constantly repeat itself, constantly cycle, constantly win a small victory against falling apart. It's a performance, not a sculpture.
And if that's true, then what is a self? It's not some little pilot sitting in your head. It's not a single point. It might be more like a resonance, a harmony, a maintained chord where all those nested vibrations hold together, just for a little while, creating a stable point of view.
Which leads to this beautiful new idea of what consciousness is. It's not a thing at all. It's an event. It's that moment of coherence, that temporary agreement when all these different clocks on all these different scales suddenly lock into phase and create one unified flowing experience.
So, in the end, this paper is really asking us to change our entire metaphor for what life is. We've thought of it as a machine, a computer, a chemical factory, but what if it's more like music? What if a brain doesn't just compute, it conducts? What if a cell isn't just a bag of parts, but a symphony?
So, after all that, where does this wild, fascinating theory leave us? Well, it all really boils down to one final, magnificent question. But first, and this is really important, let's be super clear. This is not a done deal. It's a provocative idea, a framework for thinking, not final proof. Its real value might not be in providing the final answer, but in blowing the whole subject wide open and making it feel more alive.
And that's the question we're left with. Is it possible that the very same structures that give ourselves our physical shape are also the vibrating temporal backbone that gives rise to awareness itself? Is the scaffolding of life also the timing spine of consciousness? It's just a magnificent question, and it completely reframes the entire mystery.